Database security hardening techniques for different types of databases. Introduction. Database store crucial information that must be secured. So an example is, say you run your programming system on a database so that you can or store that, or you could talk about information like how things are secured. So this is protection against breaches, unauthorized access, and data corruption, covering three database types with three hardening techniques for each database. So to start, rationalized database or RDBMS overview. Structured database with preferred schemes, uses SQL for query and data management, ensures ACID or automatic constant isolation durability compliance, popular in financial, healthcare, and enterprise applications. So in simple, so most financial firms will use this compared to, say, a tech firm. All of this is kind of similar, but we'll start with this one first and talk about its three hardening techniques. So examples are MySQL, Porsage SQL, and SQL servers. So this is the relational database or RDBMS hardening. So use multi-factor authentication, implement role-based access control or RBAC. Restricted database uses privileges. So multi-factor authentication is one of the key factors for this. It is key due to the fact that it could be used to save and restrict things. So next on that is encrypt data at rest and in transit. So use TLS for encryption data in transit, enable transparent data encryption, store encryption keys securely, and then regulate patch and vulnerability management. So apply security patches promptly, use vulnerability scans, disable unnecessary services and default accounts. So basically make sure you have locked up accounts for this one, with the storage of encryption keys securely. So keep those keys basically encrypted to the point that unless it's a public key, and of course always keep your data encrypted, as these are some of the key things to keep data secure. With the disabling unnecessary services, it could be examples of just, the simple automatic patching. You want to make sure the security patch won't screw you out of data, and depending how long that security patch takes, you don't want it to automatically update midday. So you want to apply those security patches when non-working days. So that's kind of one of those services you could do. With vulnerability scans, you could, in essence, scan for the safety of things and check that everything is going well and smoothly, and check for any like backdoors or data leaks. And then, this is pretty much the best you could do for this, for MySQL and these several services. They're, one of the key things to keep patches safe and keep everyone safe with these databases. To continue, NoSQL database overview. Designed for flexibility and high performance data storage, supports various data models and documents key values, graphs, column family, scale horizontally for large scale applications, used in big data, real-time applications, and distribution systems. Examples are MongoDB, Cassandra, and Redis. So these are some of the examples. I've never worked with them, but they are some examples of hardening. Of some databases that are not SQL databases. So basically securing default configurations, disabling public access, and enforce authentication, use IP whitelisting so that you don't have random IPs trying to attack you. And, who wouldn't disable default or public access, and then authentication. So basically making sure everyone authenticates their account, emails. Two-factor is the key for this. So as this continues, let's see. Implementing strong data encryption. Use SSL, TLS for encryption connections. Encrypt sensitive fields. Secure backup files. In essence, go in and have a secure backup so that, say, you have an attack, you can easily get the database back up and running when there's an attack. Encryption, as it says, keep that data secure and safe, and so no one can see it when it comes through. And this using these secure encryptions allows for less chance of data leaks or less chance of access to it. The last one is monitor and log-based activities. So enable audit logging so that you can see if someone tries to change some data or tries to use things or set up and use STEM tools to be able to see these logs and set up alerts for suspicious activity. And basically, as you can see the audit logs, as people change things or change data, say something disappears and people go, okay, where's this data, where'd it go? But then you can go back in and look at who changed it. And of course, setting up alerts for suspicious activity allows you to see if someone's got that back door open to the database, or be able to see if, say, one of the employees is changing the logs behind the back of everything. So this allows for freedom to kind of see what's going on and where things are. And that's kind of what these tools are good and used for. So cloud database hardening. So an example, it's just the cloud. And overall, some of these clouds are Amazon RDS, Google Cloud, SQL, Azure SQL. So example of a cloud is basically a wireless, non-on-site database. So these are like prime examples of the cloud database. And basically they're not on-site, they're off-site databases that never are used or never available to people. So in essence, using cloud provider security features like enabling secure private cloud or VPC, or using IAM policies, ensuring security groups, so setting up separate groups for each of the things, meaning, say, one person, like you have your head who can access and see what the lower heads are seeing, and then that head can't go into where the admin is, so you have the admin separate from the head of the department, which is very safe. This is kind of a security group policy. Use IAM policies, so basically just setting up secure policies to allow for things to happen. So continue regular backups and disaster recovery, so basically store backups and allow for these backups, and automated backups so that, like, say there's an attack, you can automatically re-backup these things and then test for the disaster recovery plan so that, say you have that attack happen, you'll be able to recover and get back to functioning and working order. And then monitoring and response to security threats, so enable cloud native monitoring tools, allowing you to see security threats and see what's happening, and implement automatic threat detection, so configuring alerts for unusual activities allows you to be able to see what is going on and where things are, and allowing you to look at these suspicious activities, and you can configure that if an alert happens, say the server or the database admin can go in and go, okay, this is what's going on, we need to fix this, we have this leak or this backdoor. And that's, in essence, what these hardening tools are good for. In conclusion, database hardening is essential for security. Implementing authentication, encryption, and monitoring these are key things for allowing people to keep what's going on there. And then database hardening, it's just all essential because your data is, you don't want your data to get out there. And then use cloud security features and provided threat detection, proactive threat detections. And these allow for helping to keep things down and allow you to do what is essential for these things. And overall, that's basically what you can do for database hardening and all that. And here's some part of my sources, and that's it.